Hello friends, and welcome to a lecture on operation research. Today in inventory theory, we will study about stochastic continuous review model. This is Professor Arvind Prasad. In this model, the demand is probabilistic. That is, the demand is not constant, it is random. The review of the inventory is continuous. We always continuously monitor the inventory level, and whenever the inventory reaches a critical level, the order is immediately given for fresh replenishments. Also, there is a lead time that is required from when the replenishments are ordered and when the replenishments actually enter the inventory system. Now, let's have a look at inventory level versus time. The black line represents the inventory level, the drop in inventory level when the demand rate is constant. The pink line represents the drop in inventory level when the demand rate is variable or it is probabilistic. Now let's see what is the behavior of the inventory system when there is a lead time. That is a time between when we place the order for replenishments and when the replenishment is received. Here, the inventory level drops and at point R, we trigger the demand. That is, we place the order for fresh replenishments. Further, when the replenishments arrive, by that time the inventory level drops and the replenishments are received. So there is no slackness, or there is no negative demand, or there is no backlogs. Now, demand during the lead time is going to be D is equal to D into lead time, and this should be equal to R, that is the reordering point. So, here we show what is the inventory level versus time and the lead time and the reordering point in case the inventory level falls as a curve, that is the demand rate is probabilistic. Now we assume here that the demand rate has a normal distribution. To prevent stock out, the reordering point should be equal to the demand. The z-score in any normal distribution is given as x minus mu over sigma. So the demand is going to be now mu, that is the mean demand, plus z-score multiplied by sigma, that is the deviation in the demand. Now, every z-score has a probability associated with it. This is the probability of demand. Now, the probability that the material is in stock should be equal to the probability of the demand in case we do not want a stock out. Let's say the probability that the material is in stock is L. Now, what do? For L, we find the z-score in the normal distribution table. The L probability that we have got, that the probability that the material should be in stock, for that probability, we go to the z-score table and we find out Z. So R, that is the reorder point, now will be equal to mu plus Z sigma. Now from the economic order quantity model, that is EOQ model, the Q is given as shown on your screen, where K is going to be the setup cost, C is going to be the unit cost, H is going to be the holding cost, D is the demand, and P is the shortage cost. Here in this model, we are assuming that we allow shortages. The reorder point R is going to be mu plus Z into sigma, and the safety stock is going to be nothing but Z into sigma. That is R minus mu. And the T, that is the cycle time, is going to be Q by D, and the expression for that is on your screen. Now let's take up a problem. A television company requires speakers for its television. Lately, the demand for sets has been erratic. Therefore, the average demand is 8,000 speakers per month. Now this is the mean demand, that is mu. And it may change by 2000 speakers above this. So it may change by 2000 speakers above this. It can change below this also. So sigma, that is the standard deviation of the demand, is 2000 speakers. So sigma is equal to 2000. The lead time for the speakers to arrive is 1 month. The management has also decided that the speaker should be in stock 95% of the times. Now the initial cost for catering the order is $12,000. So K is $12,000. The unit cost of a piece of speaker is $10. So C is $10. The holding cost is $0.3. So H is $0.3. Find the economic order quantity and cycle time if planned shortages are permitted. So here in this problem, we take up planned shortages too. The shortage cost in this case, P, is going to be equal to $1.10 per unit short per unit time. So that's the value of Q that we get from the formula that was shown earlier in these slides. And the value of T, that is the cycle time, that is going to be 3.6 months. Now, 95% of the times the management wants that there should be speakers in this stock. So there should be 5% chance that there is a stock out. So L is going to be 0.95. Now we go to the Z-score table. Now the closest that we find is for 0.95 probability 0.9505. And the Z for this is 1.6 plus 0.5, that is 1.65. For a lead time of 1 month, mu, that is the average number of speakers or the mean number of speakers, is 8,000 units per month multiplied by 1 month, that is 8,000 units, and the sigma is going to be 2,000 units. Therefore, R is going to be 8,000 plus 1.65 into 2,000, that is 11,300 speakers. And the safety stock, which is Z sigma, is 3,300. So that was all, guys. Hope you have understood what is stochastic continuous model, continuous review model. If you like this video, do subscribe my channel. Goodbye, friends. Have a great day.